the third version, the third way to define fault geometry for MCQ Sim 2 is this A3 GUI, and I want to start it now to show you how it works, what it looks like. This GUI, as is indicated by the name, actually imports existing fault geometry from an STL file and takes that geometry and converts it into the file format that is used internally in MCQ Sim. Okay, let's start this GUI and have a look at it. Alright, so it's quite simple. I would think the right side again deals with the boundary fault or boundary surfaces that can be specified, and the left side deals in that case with the import loading of STL files. So just simply press the button to import. In this case, I got STL files from a colleague from New Zealand. I just want to briefly show how they are imported. So you can see there's different realizations in this case. You can see one with element sizes of 1000 meters, and then these other ones with 500 meters. To make the video a bit quicker, I just import the ones with the 1000 meters. I select all the different faults that I want to import and open them. And in doing so, I can then have a look here. Right now it's still yellow, so we still import. Once this is done, this list will be populated, so you could then change the fault name and some other parameters. You could then also specify for each of these faults what the stressing rate is, what the slip rate is, and what the slip rake is. But now these values are 0 because we haven't specified it. What you can do already is plot the mesh that is already existing here. So we can go from importing it to plotting it right away. Alright, so this looks a bit weird maybe, but that's because our existing boundary surface is so far off in terms of coordinates from the other faults. In order to fix this, you can just have in this case, a very quick look at the geometry here, what the easting and northern coordinates are, and then shift this over. And otherwise we can also just delete this particular boundary fault and not use it. Alright, then we can plot again, and here we go and see the fault geometry as it was specified in an STL file. So you can see there's the big slab, subduction slab, and some other faults, some fork faults included as well. So a question could be why should we use, or why would we want to use existing STL files? Well, I guess one reason, of course, is that other people have already taken all the effort to generate these files, and it would be wasteful not to use these if they exist, if we have these geometries already specified. It also makes it easier to compare simulation results if we actually use, if different studies use the same fault geometry. So that's what we see here. Yeah, the fault geometry is here, slip rates and so forth can be specified here, boundary fault elements and all these kind of information specified here. In the end, we can save the triangulation that we created and continue to go from our A GUIs, which defined the fault geometry and meshed it, to the B GUI, which specifies some specific elements of complex rough fault geometry as well as fault strength and friction parameters. Alright.